and spend a while waiting. So now that our model is almost done, let's keep going with it and see what we can develop on next. So let's see, training output, training loss, 1.6, runtime, training loss, epochs, 2.9. Okay. What's going on, everybody? Welcome back to another Granularity AI tutorial here today. Today, I think is going to be something pretty interesting, pretty fun for the ones interested in this kind of stuff. And it's going to be fine-tuning large language models. If you're not familiar with what large language models are, think of your ChatGPT, your Google Gemini, your DeepSeek, your Claude. Those are all large language models that basically are pretty mainstream. But on a different scale, you can create your own large language model in the comfort of your own home. I might give a little peek into that. And you're able to not only create your large language model, but also fine tune it. We're not going to get into the creation of a large language model in this um, tutorial today. Instead, we are going to talk about number one, how to create your own fine tuned or how to fine tune an already created large language model. Not only that, but we are also going to do a small tutorial that's part of this one on how to upload your model to your fine-tuned model to Hugging Face. If you're not familiar with Hugging Face, I think it's the largest open source repository for machine learning. Now, I guess more so AI stuff. But when you think of open source models, open source data sets, stuff of that nature, Hugging Face should be in that same conversation. So I have a Hugging Face account. We're going to show you how to kind of use Hugging Face and how it can be beneficial for you when building or fine tuning your language models and also uploading them to Hugging Face. It's a pretty easy task. And then also with that same model that we uploaded, we're also going to use it. So we're going to run through that on the tutorial. If that sounds like something you'd be interested in, please make sure you subscribe. Please make sure you like. Please make sure you comment, leave feedback, leave criticism, dislike if you want. All I ask is that if you do decide to dislike, make sure you leave some type of constructive criticism. We're all adults here. We can take it. No big deal as long as it's helpful. Um, it sounds good to us. So, anyways, give me a little rundown on what fine tuning is. So, think of a way to create a AI. Thinking of a way of how to create an AI specific to your use case, specific to your language, specific to your domain. AI can take part in that, right? By simply, if you inject or train AI on certain data points, uh, um, certain data points, AI is able to acclimate to the data that you're injecting. So, for example, in this example today, we are going to use the FDA frequently asked questions. We're going to use an FDA frequently asked questions data set that has a bunch of questions and answers to common asked questions when it comes to FDA related uh, inquiries. Again, I have my start in healthcare. I have my start in biotech, so it's kind of my bread and butter. It's kind of what I'm most familiar with. So I'm pretty comfortable. I'm always usually comfortable playing with healthcare data or stuff that deals with the FDA because I usually sit pretty close to it. So it's very helpful for me to kind of play with this type of stuff and see what can happen out of it. And also for anyone else who may sit near biotech, or in biotech for them to kind of play with this and see what they can build out of it as well. So before we get started, I'm going to take a sip. That's good. So why is fine tuning important? For starters, it improves accuracy, tailors the model to specific tasks, leading to more accurate responses. You're able to input domain specific knowledge, incorporate specialized knowledge for niche areas. So let's say you are someone who's in oncology. Let's say you're someone who's in um, gynecology. I don't know. Think of internal medicine, family medicine. I don't know. Like all those are pretty niche areas. Or maybe you're someone who is in an engineering course and you need a large language model that's specifically tailored to differential equations. Uh, uh, or maybe you're a business student, you need business calculus information. Your the large language model that you are using can be tailored to that use case. It all just depends on what data you are fine tuning it with. Enhanced task performance optimizes the model for specific tasks like sentiment analysis. Adaptability keeps the model up to date with new data. Bias mitigation reduces bias by using balanced data. Resource efficiency saves time and resources by leveraging pre-trained models, which is a good idea. Again, building your own large language model can take time and resources. I'm going through it myself. I'm also going to give a huge shout out to Google Colab. I have become a huge fan of them now, especially when it comes to building AI applications, mainly because they do a pay as you play kind of model for when you're training AI models or when you're building AI models. They have A100 GPUs, T4 GPUs. I forgot, they have one more that I can't remember. Yeah, A100 GPUs, T4 GPUs. Let me see, there was one more I'm forgetting actually. Um, L4. I'm going to be using, majority of the time, I'm using T4. They are less expensive, uh, less energy intensive. The models that I'm building aren't going to be, I don't, at least maybe not right now, I don't plan for them to be used uh, by the globe, so they don't need to be that energy intensive. But whenever you are building these scalable popular AI models, you usually do want to use like an A100, which I think A100 is like the most popular GPU out right now from NVIDIA. And then last but not least, customization aligns the model with specific organizational needs. So again, if you work in a certain domain space, a certain organization, a niche domain space, a niche organization, having an LLM, excuse me, having an LLM that's specific to your information can be extremely helpful. Where if there's a data set out there that kind of correlates to whatever you're working on, and it can answer questions easily for whatever you're working on, highly recommend just training a training a already pre-trained model like an open source model, like a GPT-4 if your organization allows that, stuff like that. That can be very, very helpful for you. So, anyways, moving on, we are going to now get into something fun, which I think is what most of you guys want. First, I'm going to explain the Hugging Face interface. So, for example, we have the granularity account. You're able to see kind of what models I've liked. I am a huge fan of Hugging Face. You're able to get access to different open source data sets. For example, you are able to find the data set I'm using. If you type in FDA, FAQ, you'll see the JMax created this in March 12th or updated it March 12th, 2024. FDA Pharmaceuticals FAQ. Highly recommend checking it out. A very simple data set. I think there is 16, maybe almost 1,700 rows of pharmaceutical FAQs. If you are familiar with like GXP, if you're familiar with regulations, FDA regulations, and how tedious it can be when you are doing collaborations with the FDA, you'll know that this data set can probably be helpful for whatever model you're training. So highly recommend taking a look at it um, and yeah, having a crack at it. Anyways, so moving on from that, you're also able to hop into the the open source models. This one I'm actually pretty excited for. This One AI Want to. If you're not familiar yet, this is the text to video model, I think from Alibaba. This is not, we're not going to explore it in this video. Maybe in a future video we will. Um, but I'm excited to kind of see what that's like. Also, DeepSeek is in here. Perplexity is in here. What else? Omniparser is in here. I think Llama also you'll find in here. Oh yeah, MetaLlama 3.2, 7 billion, 1 billion, blah blah blah. So again, if you are into open source models, this is kind of what you want to use. This is where you want to be. This is what you want to explore. They have filters that you can play with. Shout out to Hugging Face. I think this is extremely awesome. I have become a huge fan of Hugging Face since DeepSeek. Honestly, huge fan. I think I really wasn't a huge fan even when the llama craze was happening, the old llama craze was happening. But since DeepSeek R1, and me wanting to use it, I'm a huge fan of Hugging Face. So shout out to them. Also, I am not sponsored by Hugging Face. I'm not sponsored by Google Colab. This is just pure appreciation. Again, please make sure you hit that subscribe button. Please make sure you like. Please make sure you leave feedback, comments, dislike if you want to. All I ask is that if you do decide to dislike, please make sure you leave constructive criticism so that we can give you the content that you want to see. So let's jump into the exciting part. Like I said before, I am using Google Colab. Let me kind of move my face out of the way. So data sets, which is kind of Hugging Face's package to load different data sets from the Hugging Face site. Bits and bytes, this is something to optimize your pre-trained model or optimize the model itself to then perform better. It can be a hit or miss. I think I already kind of had this installed already. I don't think it's really that needed, but since it's already there, I kind of just install it anyways. One thing I want to make a point about when it comes to the reason why I've began to love Google Colab is the runtime options. So here, we're using the CPU. We're going to go over to the T4 GPU. Changing runtime attribute, yes, we want to do this. Save, and then we can see it connecting here. It takes some time, but this is something that is super important, right? For you, for individuals, for you, whoever that may not have the extra, I don't know, few $100s to throw to a GPU that you might buy online or from whatever parts store you go to. Let me kind of refresh this. It's taking kind of a while. Reload. Let's see. T4, save. Nice. Okay. Let's run these real quick. The green ellipses is what you want. That means it's connected. But anyways, as I was saying, once you or if you do not have the means to buy, multiple GPUs to train, or an A100, I don't even know how much an A100 costs, or even a T4, I'm not even sure. I know T4 is kind of the least expensive out of the ones that are popular. But if you don't have the means to buy one of these GPUs, I highly recommend just to go to Google Colab and use their pay-to-play kind of option. I think it's $10. You get access to, I think you get access to, I forgot, I don't know if it's 100 compute units. I can't remember, but you get access to a substantial amount of compute. $10 doesn't seem that bad. Um, even for me, like usually, even for me, like usually I don't, unless I'm working on a project. Um, Maybe then I could see where you would want to buy like your own GPUs if you're working for like a proprietary project. Understood. If you're just kind of experimenting, if you're just kind of exploring, seeing what you can build, minimal stuff, whatever it may be, doing minimal training, I would just go to Google Colab and use their options when it comes to what you can use, whether it's CPU, A100, stuff like that. There's not really a need all the time to use um, your own GPUs that you've bought from whatever store. I think it's better just to use these that are offered. One thing that I do want to mention is you want to make sure that you do have a Hugging Face API key. You can find that in your profile option on the top right of your where your profile picture is. You can find your API key by accessing that, the tokens and whatnot, and generate your own. So as we're going, I'll kind of explain all the steps that you want to do. I will be copy and pasting from a past project into this one, just so we don't take too long in this tutorial. But adding to this, let me kind of make sure I run this to add my API key. There we go. Adding to this, right, I want to give you an idea on the data set that I'm going to be using. So here, you want to use, again, this is where this package, this data sets command comes in. Whereas you will load in the data set using this package. So data set equals load data set. This is kind of the easy way where you're able to access data sets from Hugging Face, load them into your environment. And just to give a better picture, here's the data set that we're going to be using. So as you can see, bunch of FDA questions, bunch of answers to those questions. Description: this dataset contains a collection of question and answering pairs related to pharmaceutical regulatory compliance provided by the Food and Drug Administration. It is designed to support research and development in the field of natural language processing, particularly for tasks involving information retrieval, question answering, and conversational agents within the pharmaceutical domain. Highly recommend using this if you are someone who is in pharma, biotech, healthcare, whatever it is, and you're thinking of kind of building an AI application. Have at this one. I think this can be extremely helpful for you. I'm probably even going to use this one further in the future, to be honest. So I think this is a good data set. Shout out to JMax, whoever that is. So let's keep going. So now that we've loaded our data set in, you can see blah, 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 readme, train, CSV, validation. It's loaded all the items from the profile itself. You can see it. Let me see if I can find it. Oh, no, it's not in this one. Okay, yeah, it loaded all the items from the data set itself. So let's keep going. And here's where we're processing the data set to then use the correct columns. So we're going to want to do def pre-process, not examples, but just example. Boom. And then we want to do return prompt. Forget the yes prompt. Boom. F. Question. Example. question, example, blah, blah, blah. Boom, boom. Question, da, 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 da. Slash answer. Cool. Then we're gonna do one more data set. Boom. So this is going to be able to process the data set we're loading in um, to then get ready for the model that we're going to be using. So let's go ahead and run this. Cool. Now for this also, we're going to be using the TinyLlama model. And we're also going to be using this as the tokenizer. Cool, so let's keep going. Now, for the next piece, we're going to be creating the tokenizer function and adding labels for causal language modeling. So let's kind of add this. Tokenizer prompt trunk to the max length to the yes. Okay, cool. And this is going to kind of be able to help us in making the model more efficient and collecting kind of the unuseful items within our code. And we're going to kind of use something called a garbage collection callback, which this just helps us optimize its performance as well. And then here we go, defining our model using the tokenizer or using the model that we created earlier. Not created, but the TinyLlama that we defined earlier, TinyLlama model. Now, sometimes if you are going to use just your CPU for this, it could take a while. Highly recommend don't just using a CPU. It could take an hour or two. Use the GPU option again because it's faster, it doesn't take as long, and it's not as intensive on your PC. Also, it's not that expensive when it comes to using it with Google Colab. Let's keep going here. Model, gradient checkpoint, dot, gradient, checkpoint, pointing, underscore, enable. There we go. This one. Don't forget to add parentheses. Nice. Now, Laura, let me kind of sound this real quick. Now, Laura is something also of an optimization, I guess, package that you can use too. Highly recommend using this. Great for also causal language modeling. If you're familiar, I think if you're familiar with machine learning, Laura is part of there too to optimize kind of ML models. I'm not 100% sure. I think I've seen in the past. I think I might have used it too, but I can't remember. It's been a while since I've touched on ML stuff since this kind of AI thing blew up. But I believe it is possible to use in ML modeling too. Model equals get underscore P EFT. Yes, this one. And then model Laura config. And then we want to add our collator for the tokenizer. So let's do that. So data, collator, blah, blah, already knows. Nice. Tokenizer, MLM, false, beautiful. So this is going, now we want to define our arguments for training. This one I'm going to copy from the past project I did. So this is me kind of defining the director I want to use, batch size, gradient, accumulation steps, number of epochs to use. Learning rate is kind of important. I would look into what best fits for the LLM you're using. I wouldn't just define it at random. I would definitely do a little bit of research into kind of what is the optimal learning rate for, I don't know, any open source model, whether it's a GPT model or whether it's a GPT model or an open source model like a Llama or a DeepSeek. Kind of look into what other people have used, what other people think is best, depending on your GPU as well. I would look into that. I wouldn't just kind of freeball it and see what happens. But anyways, let's go ahead and run this too. Nice. So now we want to make sure we can see the splits that it's done. Make sure everything looks right and is correct. So available splits, dataset dot keys. Boom. Then if train not in dataset, boom, tokenized dataset equals train. Train tokenize. There it is. Boom. So what should happen is it should pop out or outputting that in our data set we have our train column or our train data set, or not data set, but keys, train, validation, and test within our keys. Over, comma. There you go. Now here's where we begin to define or begin the training for the model itself, using the arguments that we created, the model we created, the data set we created. So let's go ahead and tokenize data set not found. There we go. Let me see. Yes, one thing I did forget to include was the tokenized data set itself, or define it. Let me see. Tokenizer function. Here. Definition. Tokenized. Tokenized data set. Equals dataset.map. Okay. Nice function. Let's do batch to true, but the size Number, we're going to change this to batch size equals 32. And then remove columns. We change this from to columns. We're going to do question, answer, let's put answer on, answer, prompt. I think that data set a map, tokenize function, batch to true, batch size, remove columns. Nice. Excuse me. Okay. Nice. And then let's rerun this now. Okay, now we're good. Now we're still cooking. Okay, so let's keep going. Once we have finally fixed that error and defined it, we are now going to run into trainer.train. And this, again, takes a while once you're training it. If you're using a CPU, so again, highly recommend using Google Colab and doing the pay as you go kind of model for getting access to GPUs. But anyways, let's run it and see how it goes. So this, again, might take a while, so make sure you grab yourself something to drink, some water, soda, tea, whatever you decide to sip on, and spend a while waiting. So now that our model is almost done, let's keep going with it and see what we can develop on next. So let's see, training output, training loss, 1.6, runtime, train loss, epochs, 2.9. Okay. Not bad. Let's go to, we want to save this model now in our file space here. So we already kind of have the folder. So let's go ahead and do model underscore save path equals, and we want to take the path here, copy path, boom, equaling, but instead we just kind of, we don't want all that. We really and truly just want to do like this, boom, and that should be good. Then we also want model dot save underscore pre-trained model, boom, and then we also want to do that. Think that, blah, blah, blah. Make sure I take this back. Let's close this a little bit. Model save path equals FDA. Oops. Save model path, blah, 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 tokenizer. So yeah, that should be good. Then once we run this, what should happen is we'll see all those files now here. Tokenizer JSON, tokenizer config. Cool. So let's keep going. Now we want to make sure that just to make sure that to print out where the model path is, if you want to double check, boom, nice. Next is the fun part that I think a lot of us are waiting for. Again, if you've enjoyed this video, please make sure you subscribe. Please make sure you hit that like button. Please make sure you leave comments and feedback. Dislike if you want to. All I ask is that if you do decide to dislike, please leave some type of constructive criticism so that we can kind of give you the best content that we can provide. So let's create a few spaces here. Code, code, code. And now we're going to go to the Hugging Face part of this tutorial. So we're going to do a pip install for Hugging Face Hub. And then you also want to do a installation of the Hugging Face CLI. Again, you want to use your token here. You'll see this message, and again, you're gonna get an error message either way. It's gonna be intimidating. Don't worry about it. You'll be okay. But you want to hit yes for this. Token has been saved to get cannot get blah, 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 blah. Don't worry about this. You try to say blah blah blah. You just want the login successful part, and you should be good to go. After you've done that, you then want to push the model into your profile, or your repository profile, or you want to call it a Hugging Face. Push to hub, boom, boom, and you want to use, for example, your profile name, which in Hugging Face for us is GrandU AI here. And then we're going to call this TinyLlama 1.1 billion chat _ FDA _ FAQ, just to make sure we know what data set was used for this. Boom. And we are going to do the same thing for this, but this will be for the tokenizer itself. Tokenizer. So again, you want to run this, repo ID, namespace, blah, blah, blah. Oh, I see. Whoops. Didn't know I did that. There we go. Now it should work. And what's going to happen is we're going to go back to the Granularity Hugging Face site, and you'll see that we finally have a model that is fine-tuned with the FDA dataset, where we can then use and ask it questions related to FDA stuff. And it should provide, hopefully, a comprehensive answer. So let's give it some time. Cool. So we have no files have modified since last commit, scheme to prevent empty commit, blah, 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 have modified since last commit, scheme to blah, blah, blah. So now if we go back to where we have originally saw that we had no models in our site, we now see that GrandU, TinyLlama, blah, 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 chat FDA FAQ has now updated less than a minute ago. We can go in here. We can edit the model card to provide maybe a comprehensive details on what this model does, with also how to kind of use this model. So we're using the Transformers library to kind of play with this model in Colab, and it kind of gives you a detailed idea on how you can kind of load it in. Now, one thing I want to state is when you are using Hugging Face to load a model, you want to make sure you select the correct types of metadata. So I think for this one, we used what? TinyLlama? Yes, I think it was chat. Let me see. Yes, 1.0. Auto detect. You want to add text generation for, or for this specific model, it's going to be text generation, but based off whatever you're using it for, you want to kind of make sure it has the proper tags, the pipeline tag. So healthcare for this, biotech for this, pharma for this, and let's do medicine. Data sets, FDA by JMax. Cool. Now go ahead and save this or commit it, commit changes. And then you'll see it finally has all this metadata added to it with the pipeline specific to this model. So now that we kind of have all that saved, let's go back here. And then let's go to the space again. And now let's use this model. So what we want to do is we want to do messages equals kind of similar to old school OpenAI models. Messages, boom. I don't do it that far. Boom. Roll. We're just gonna do roll. Roll. User. Boom. Content. Boom. And now let's ask it a question. So let's see here, just to kind of bring this back. So in the JMax data set, we have, as for the details of medical device reporting for manufacturers, guidance for industry and food and drug administration staff, study design and methodology, blah, 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 blah. Firm should include accurate overview of the design, blah, blah, blah. That's like a question. Let's see, what about this one? In light of the details from assay migration studies for in vitro diagnostic devices, guidance for industry and FDA staff, where can I find information about PMA approvals? We'll see. Oh, no, that was too simple. Having read through ANDA's stability testing for drug substances, when do intermediate stability... I might take this one. When do intermediate stability studies need to be initiated in the event of a failure at accelerated condition? Let's try this one. Cool. So we have content. We want to place or paste the question that we just had from the original data set into here, see how it answers and see how it performs. Add a comma, and then you should be good to go. And then pipe equals pipeline, or you could just copy it from the site itself. You go here, use model, boom, and you simply copy this part, boom. I gotta make sure I include the package as well. Do that. And then let's make sure we add here. Now, what we expect to happen, also make sure you define max tokens as well. Max tokens, max new tokens equals, we're going to set it to 1,000. Again, this is open source, so you can kind of use as many tokens as you want. Don't go crazy, I guess. I don't know if there might be limitations necessarily. But yeah, I usually put it to 1,000 and see how it kind of runs. That's what I would recommend. So now let's go ahead and run it and see what it spits out. We want it to spit out this, or at least close to this answer here. The AND applicants should start accelerated, intermediate, and long-term stability studies at the same time, so the data are available at the same time submission, blah, 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 blah. We kind of wanted to state the same thing more or less, maybe a little bit longer, maybe a little bit more explanatory since we have 1,000 tokens that we're using. But let's go and see what happens. Give it some time here. Again, if this tutorial has been pretty explanatory for you, please make sure you subscribe, like, dislike, comment, leave feedback, leave constructive criticism. We love it all. So, let's see. Intermediate stability studies are initiated in the event of a failure at accelerated condition if the failure is due to change in stability profile of the drug, substance, or product. This is because the accelerated condition is used to stimulate the conditions that the drug will encounter in the clinical setting. The stability profile of the drug, substance, or product is critical in ensuring that the drug is safe and effective. Therefore, failure to accelerate condition indicates a change in the stability profile of the drug, which requires further investigation to understand the cause and develop a solution. Let's try another question and see how it answers. This was a pretty explanatory answer, pretty well written. Let's kind of see what else we can ask it real quick. I'm considering information. Blah, blah, blah. Let's see here. According to the guidance for industry interim procedures for qualified health claims and the labeling of conventional human food and human dietary supplements, what form must be used to notify the FDA? So here we see in this question, there is no official form to use. You may make the notification by letter containing the required information in any format that is convenient to you. Again, the expectation is, since we're using 1,000 tokens, the answer to this question should either be pretty explanatory that there is no official form to use, or it might include other details it found in the data that we injected it or injected with it. So let's go ahead. Guidance for industry interim. According to guidance what form must be used. Guidance for industry procedures for qualified health claims in the labeling convention of human food and human dietary supplements requires that the form must be used to notify the NDA. I don't like that answer. Let's try a different one. That one wasn't really good. Again, depending on how much data you load into it, it could be a hit or miss. So this question clearly needs a bit more training to it. This one I didn't really like. Let's try another one. That one wasn't very explanatory, nor is it offering too much explanation. Let's see. Taking into account the content of blah, blah. So I see here, this might be a good one. As stated in the quality systems approach to pharmaceutical current good manufacturing practice regulations, can FDA investigators take photographs of objectionable practice and conditions? It is the agency position that photographs can be taken as a part of the inspection, and this position has been sustained by a district court decision. So again, looking for an answer that either is pre-explanatory to this or exactly this, whichever one. This isn't, what people confuse is fine tuning with RAG when kind of incorporating data sets into it. It's not necessarily going to pull the exact answer from the data set, but instead is going to use the questions and answers from the data set to formulate the LLM's own output, not pull the exact reference, which is kind of similar to what a RAG model would do. So let's go ahead and use that question here. Boom. And let's see what answer it spits out. So again, This only had 1,700 rows of data in it. Again, there's other data sets that might have billions or hundreds of thousands. Um, it all depends on how well you're training the model, right? Of course, this is TinyLlama. I wasn't planning to incorporate billions of rows or millions of rows into this data set. Small data set into TinyLlama kind of makes sense to then train it. But anyways, so as stated in the quality systems approach to pharmaceutical current good manufacturing practice, yes, FDA investigators can take photographs of objectionable practices and conditions during their inspections. This is a standard practice in the quality systems approach to pharmaceutical current good manufacturing practice regulations. The photographs are used to document the inspection findings and to provide evidence for future regulatory actions. So pretty close to what we already kind of had in terms of the answer we had originally from the Q&A data set we have here. It is agency position that photographs can be taken as part of the inspection, and this position has been sustained by district court decision. So yeah, pretty close to what we kind of already had created or had in the data set. So again, fine-tuning a large language model is a great way to curate a model to your liking for whatever domain you're in. Again, this is specific to biotech, pharma, FDA stuff. If you are in that space, you know that this can be a huge opportunity for anyone to kind of use in biotech or in pharma. Regulatory agencies can be a pain in the neck. If you can have a LLM or a bot of some sort that let's say a clinical trial professional or a medical professional can go to ask questions of, hey, I don't exactly know about this particular thing when it comes to if the FDA approves or disapproves of what I'm about to do. Let me ask this LLM to make sure I am meeting good manufacturing practices or good experiment practices, whatever it may be, the whole GXP kind of thing, good documentation practices. Let me ask this LLM for help and see if it can kind of educate me on what to do next. So yeah, this is kind of one way to do it in terms of fine-tuning your own LLM or fine-tuning a pre-trained model to then curate it to your liking. If this is a tutorial you felt was informational, I know it ran kind of long, probably the longest I've done so far. And if you found this tutorial pretty informational, please make sure you subscribe. Please make sure you like, make sure you dislike. If you do dislike, make sure you leave comments, suggestions, feedback, so that we can provide you the best material we can. And with that being said, bye-bye.